All right, ladies and gentlemen, today we're going to be naming some hydrocarbons. And as their name suggests, hydrocarbons are a special type of organic molecule or a special type of compound that's a little bit different than the other ones we've been naming. Now, we've been working on ionic, we've been working on molecular. Our next type is our hydrocarbons. So, ionic, we look for metal and nonmetal. Molecular, we look for nonmetal, nonmetal, our covalent molecular formulas. And we know that for our molecules, we use these prefixes. For ionic, we don't. For our hydrocarbons, we're looking specifically for a carbon bonded to a hydrogen. So our hydrocarbons, we've got a special type of hydrocarbon that we're going to be naming at our Chem 1 level, and that's our alkanes. This is a specific class of organic compounds made up of only carbon and hydrogen using only single bonds. Now this is important because there are other types of hydrocarbons. There's alkenes and alkynes, but we're not going to name those. We're just going to focus on the alkanes. And these give themselves away because there's only ever two types of elements. It's going to be a carbon and some hydrogens. So when we come across these hydrocarbons, there'll be a carbon followed by a hydrogen, and then there'll be some amount of the carbon. So here our X represents the number of carbons in there. The H represents the number of hydrogens that are in the compound. And so by looking at the number of carbons, we can start to figure out what the name of our hydrocarbon will be, because the name is directly dependent upon the number of carbons in our hydrocarbon. And so what we do is we look at that X. We say, okay, we've got carbons and hydrogens. It's a hydrocarbon. It's not molecular. Well, kind of molecular, but it's a special kind of molecular. It's not ionic because carbon is very much a nonmetal. And so our carbon-hydrogen combo makes our hydrocarbons. We say, okay, how many carbons are there? If there's one carbon, we're going to use the prefix meth. If there's two carbons in there, we're going to use the prefix eth. 3 carbons, we use the prefix prop. 4 carbons, we use the prefix bute. And those first 4 are kind of goofy, but once we hit 5 carbons, 6 carbons, 7 carbons, 8 carbons, 9 carbons, 10 carbons, it's really nice because our prefix is the same as the prefixes from our molecular formulas. 5 we use pent, 6 carbons hex, 7 carbons hept, and so on and so on. Now, to indicate that it's an alkane hydrocarbon, the kind of ending or base of our name here is going to be the ending ane, A-N-E. So, if we were looking at an example, for example, CH4, now it's not written here, but C, we've got an implied 1, so 1 carbon in here, there's only 1 carbon. We're going to use the prefix meth, and we're going to make the ending ane. So CH4, that's methane, which is what we use for our Bunsen burners. Another example, this would be, for example, C3H8. Well, C3, 3 carbons, means that it's prop because it's carbons and hydrogens. We're going to call it propane, so propane. C3H8 would be propane. Another example, C6H14. Well, we say how many carbons are in there? We've got 6 carbons. Well, 6 carbons, that's hex. 6 carbons is hex. We're going to name that hexane. Now, again, 5 through 10, super easy because they're the same as our molecular formulas. But 1, 2, 3, and 4, meth, eth, prop, and bute, they're kind of goofy. And we could make flashcards, but we could also just make a little saying. And the one that I like, use it if you want to. I know it's not proper English, but me eat peanut butter. Me eat peanut butter. Kind of think or my elephant prefers butter, whatever you want. Me eat peanut butter is what I like to use. Me is meth, eat, eth, peanut, prop, bute, butter, bute. Me eat peanut butter. So if, for example, it was C2, me eat, E is eth, and we would call that then ethane. So when we've got the formula to go to the name, we just say how many carbons are in there. Find the corresponding prefix, slap the ending ane on there. Really kind of nice. Now to go the other way, there's a really nice pattern to help us go the other directions. So for example, if you were given the name, you would look, if you're given the name, yes, you would say, okay, from my prefix, how many carbons are in there? So for example, if it ends in ane, we know it's a hydrocarbon, and then we say, okay, how many carbons are in there? If it was C2H6, what, for example, C2H6, well, C2, me eat. So 2, that would be 2 carbons. Then we just got to figure out how many hydrogens are in there. To do that, we take the number of carbons times 2 plus 2. So if it was ethane, for example, me eat, that would be 2 carbons. 2 times 2 is 4, plus 2 more is 6. It would be C2H6. Another example of this would be, for example, decane. Dec, that's 10. So it would be C10H, well, 10 times 2 is 20, plus 2 more is 22. Give an example of this. Butane, bute, me eat peanut butter. Butter, bute is 4, so C4. 4 times 2 is 8, plus 2 more gives us 10. We already saw the example decane. Again, dec meaning 10, so C10. We then take that times 2 is 20, plus 2 more is 22 hydrogen. So again, we've got flashcards for these, but really if we can kind of see this kind of pattern, it's much, much easier just to know our pattern here and then use the prefixes from before. Awesome. This is how we name our hydrocarbons. There'll be more practice coming your way.